Have you ever looked at individual sign letters on a wall that are backlit and wonder how are they made and how are they mounted to the wall? In this video, I'm going to show you how to design, cut, wire, and install single letter signs like this one so you can get perfect results and professional results every time. A week ago, I posted a video and some photos on social media showing a new Learning Center 3D letter backlit sign that we did in our facility. And I asked everybody if they would like to see a tutorial. And I was really blown away receiving literally hundreds of comments and emails with people saying, yes, they would love to see a tutorial on how a sign like this is not only designed and cut on the CNC, but also how the LEDs are wired and how it's installed on the wall. So I'm going to do my best in this video to kind of break it down and to show you exactly what I did and to get, professional results. Some of the tips that I'm using here I got from other people that I know that are in the sign industry. So, I did a lot of research to figure out the best way to do it, which hardware to use, etc. So I'm going to share all that with you in this video. Now, here's the sign that I have that's installed in our facility, and here is what it looks like on the wall. Now, what I started with basically was that I needed a physical size for the sign, and I knew in this case that my overall door width was 64 inches, and I had about 16 to 18 inches to play with. So I set up my job size to be 64 by 16, knowing that I'm going to center this sign up vertically on the wall above the door. And for right now, the thickness doesn't really matter because we're going to go and change that a few times. But that's how I set this up. And that way I can arrange everything the way I want. I could center it vertically and horizontally. And I could scale the letters to a size that I want based on the amount of space that I have on the wall. Okay, so that's the first step, is decide what size your sign is going to be and make your work area the physical size that you have to work with. Another thing you could do is if you had a work area that was, say, a wall and it was 10 feet long by 8 feet tall, you could actually change your job size to be the size of the wall. So now what you could do is take a look at what your sign will look like to scale on the entire wall, and that'll help you visualize whether you need to make the sign longer, taller, or just scale it proportionally to fit that given area. Now, once you get the size the way you want on that wall, you will have to rescale, not rescale, but you'll have to resize the job size back down to your work material size. So whatever material you're going to be putting on your CNC. But this is a good way of using Vectric to kind of visualize what something will look like to scale on like a large wall or even a building or something of that nature. So in this case, this is what I have for my job size. And now what I'm going to do is I'm not going to go into detail on how I did each and every letter because the process is pretty much the same. But what I am going to do is I'm going to take the letter E and I'm going to show you how to design that and how I set up the LEDs and the standoffs, etc. And the reason I'm going to show you the letter E is because we had to actually solder a couple of strips in the letter to get the LEDs to lay flat. Like for instance, the letter L, you could pretty much lay the strip flat and then kind of make a slight bend in the corner to get it around. But you have to deal with the E, so you have to have at least one solder joint to get the LED strip to lay in the E there correctly. So I'm going to show you that letter. Now in this particular sign, all the letters are 5 inches tall. So I have a lot of different, this is the final working file that I use. So there's a lot of toolpaths here and there's a lot of layers. I'm not going to get into everything, but I made a separate layer here called letter E, and I am going to work right now just on that particular layer. So we'll zoom in a little bit so you can see that. So here's my letter, 5 inches tall. The width is roughly 5 inches or so. It's scaled proportionally. The font I'm using is a font called Blair ITC. It's just happens to be a font that we use as a standard for our marketing and branding. Now the next thing I did was I measured the width of the LED tape to see what my pocket width has to be inside the letter. And the LED tape I'm using measures at 0.32 inches. So what I think I'm going to do here on these letters is give them a 0.2 inch sidewall, which should give me right around a 1/2 inch or so pocket width on the inside. So being that the tape is 0.32, having a 0.5 inch width pocket gives me a little bit of freedom in there, especially if I have to bend the tape around the corners, it won't be so tight. So to do that, to set up the pocket, all I'm going to do is come over here to the offset selected vectors button, and I'm going to offset inward by 0.2 inches. And I'm going to make sure create sharp offset corners is checked. Delete original and select new will be unchecked. When I click offset, you can see now I have my sidewall here, which is, if I measure it just to show you, it's from here to here. And it's exactly, if you look over here where distance is, it'll say it's 0.2 inches. So that's my sidewall all the way around. Now, if I measure my pocket width, it's roughly 0.4656. So just under a 1/2 inch. So I still have plenty of room given the fact that my LED tape is 0.32 inches. Okay. So that's basically all there is for setting up the pocket of the letter. Now, the next thing we need to do is figure out where we're going to put standoffs on here to mount the letter to the wall. The threaded inserts I like to use are from a company called EasyLock. So their website is ezlok.com. The nice thing about these is they're a really good quality threaded insert, but they're also available on Amazon. So if you're in a hurry for parts like I was able to get these delivered next day. So there's a few different types. They have ones for metal, ones for wood, and ones for plastic. Now, I am using PVC for the letters, or Sintra, for the actual letters, which is technically a plastic. However, I'm not going to use plastic inserts. If I was using a denser plastic like HDPE or acetal, I would use a plastic insert. But the consistency of Sintra or PVC is very similar to that of a softwood. And I find that the wood ones work better in that material. So if we click on wood, we can see that they've got a couple different types here. I don't use the finserts, but I have used both of these. There's a knife thread, which has a solid thread around it that basically cuts into the material as you tighten it in. And then there's the hex drive inserts, which have like a sawtooth flange. These are designed for softwoods, where these work better in hardwoods. So since, again, I'm using Sintra, which is more like a softwood, I'm going to go with these inserts. So if I click on that, there's two types of inserts. There's a flush mount, which when you tighten this up, the top of the insert is actually flush with the top of your material. And then there's a flange mount, which the flange can sit above the top of the material slightly. In this case, it didn't really matter because the inserts were inside the letter. They weren't actually going to be seen. So I opted to go with the flanged only because they were available for delivery next day. If the flush mount were available for delivery next day, I would have used those. So it really didn't matter in my case which one I went with. However, I did go with the flanged ones. So the next thing I want to do is look at the dimensional drawings here. And I'm using Easy Hex drive flange for softwood. So I want to download that. Then they give you this nice sheet here. Now, the inserts are made for several different thread sizes, 832 being the smallest all the way up to 3/16. Then they have, 3/8, and then they have metric as well. Because these letters are only 5 inches tall and only weigh a few ounces a piece when they're done, I opted for 832. That will allow me to not have to make such a large pocket inside of the letter to handle this diameter, and that gives me more room to have LED strip in there. So the fact that these letters don't weigh anything, 832 threaded rod and inserts are going to be fine. So there's three dimensions actually we need in this chart that we've got to record the dimensions for it. The first one is the overall length, which on this one it's 0.394 inches. The next thing we need to look at is the overall width or the diameter of the flange, because that's the largest part of this threaded insert. So that's letter F, and that's 0.329 inches. And then the last thing we need to know is the hole diameter that we need to make in order to thread this insert into it. Okay, so the drill size is the next dimension we're looking at, which is 15/64, and in decimal, that's 0.234 inches. Okay, so those are the dimensions we need. That's all we need from this chart to get back to the project here. Now, the placement of the threaded inserts, I like to use opposite corners if I can, because if I use two inserts at the top, the letter could have a tendency of kind of leaning down and the bottom of the letter leaning inward towards the wall. And I want the letter to sit parallel to the wall. And I find that by putting them in opposite corners, and once you push the threaded rod into the wall, it stays nice and parallel and in place. To do more than two is really unnecessary because, again, the letter doesn't really weigh anything. You're just making more work and using more hardware. So I opt for two, and I do them cross corner. Now what I will do is I'll put one in the outside corner here and then one on the inside corner here. So the next thing I need to do is draw some circles. Now the first circle I need is the overall flange diameter, which is 0.327 inches. And we'll go ahead and create that circle. The next diameter, or the next circle that we need, is going to be the hole diameter, which is 0.234. And we'll go ahead and put that right in the center. The length measurement we'll get to later when we do the cam. Okay, so I'm going to take these two and I'm going to move them manually. Now, what I need to be careful of is the hole is actually going to be a pocket, and it's going to go down. The center hole is going to go down a minimum of 0.394, which is the overall length of the standoff. The outer circle will be a pocket, but it only has to go down to where the flange is going to be. So I need to be careful that I don't take away too much meat out of the sidewall of this letter, or it'll get really flimsy and frail in these corners. Okay, so what I like to do is move it down so that the corner of the inside of the pocket, it matches up with the edge of the actual hole that you need to make for the insert. Then the flange will actually just get machined away from the sidewall, but since you're only going down a little bit, you're not really taking away from the structure of the sidewall of the letter. So that's where I'm going to leave this one. And now I'm going to go ahead and make a copy of it. And this will go in the other corner. Now I apologize, I'm using a Mac mouse and it's really sensitive for the zooming, so I don't mean to make you dizzy here. I'm going to go ahead and just move this roughly to that corner. Now, in this case, because it's going on the inside of the corner, I'm not as concerned about my sidewall width here because there's actually quite a bit from the edge of the circle to this inside corner. So what I'll do here is just arbitrarily put this circle. I want to put it so it's relatively the same dimension here and here. I want to make sure that I've got enough room for the LED tape to go by. So that's my biggest concern. So I'm going to leave this here right now. And then I'm going to go ahead, and I know that my LED tape is 0.32 inches. So I'm going to measure from this point to the sidewall, and I've got 0.34 inches, so that's good. And then I'm going to measure from this point to the sidewall, and let's see, I've got 0.26 inches. I'm okay this way, but I need to move the circle up in this direction. So I'm going to go ahead and highlight that, just move it up a little bit. Measure it again, and now I've got 0.29, so I'm going to move it up just a hair more, and I'll measure it again, and we should be at 0.33, so we're fine. So that means the LED can pass through both directions right here, and I'm not going to have any issues right there. Now, I could have positioned this with an actual position indicator, so I could have highlighted this and then gone to move selected objects, and I could have either from a relative position from where it was, I could have said, okay, move it up 0.3 or 0.2 or whatever that dimension would be. I just did it kind of the long-handed way, but if you know that you measure and you're 0.26 and you know you need a minimum of 0.32, then you could subtract the 2, and that's the value you can put in the Y position, and that would have moved this relative to where it was before. So you can, again, do it any way you want, but you want to make sure that there's enough room here and here for the LED tape to pass through. That's the bottom line. Now the next thing I'm going to do is I am now looking at the front face of this letter, but the pocket actually has to go on the back side of the letter. So that means I have to take this entire letter and I have to flip it. But before I do that, I want to make a copy of it as it is right now, and I want to transfer that a copy. So I'm going to go to copy to layer, and I'm going to set that. I have a new layer called letter E acrylic, and I want to make a copy of these vectors, and I want to send them over to the acrylic layer. So now I have a duplicate copy here on the acrylic layer, and then I have the working layer that we're right now. So I'm going to go ahead and flip this. We're going to go to mirror selected object and flip horizontal. So now I'm looking at the back side, and this is how I want to machine in the material and create the pocket. So the next thing I have to do is get the scissor tool. There's some vectors here that I do not need. Right now, the circle, the small circle, is the hole that we're drilling or milling out for the threaded insert. So all I want to do is just see that circle. That means I do not need those vector lines that are inside there. The other thing is this larger circle, I'm going to pocket down for the flange, so I do not need these straight vectors that are right there. So I'm going to do the same thing over here. Get rid of these vectors I don't need. Okay. All right, so now I need to create the vectors that we are going to machine around. And if you look here, I'm going to machine around the inside of this vector here and this vector. So I want to machine basically around the inside of these pockets. Now, I have this flange here and then the hole. So what I need to make sure is that it's important for me to have this much material outside of the hole that I'm pocketing out for the threaded insert so that there's something for the threads to bite into. So what I want to do here is I want to machine up to this point and then around the perimeter and then continue on. So what I will do here is basically I'm going to create a copy of this vector, and then I'm going to come over to the scissor tool and I'm just going to clip this outside. And what that'll do is connect that. So now I have my inside pocket. Then I'm simply just going to hit the paste key or Control V, and that's going to put the circle back because I'm going to need that circle for a vector to machine later. So I'm going to do the same thing over here. I'm just going to Control C or copy that. Then I'm going to grab the scissor tool. Now this time, this is the inside of the pocket. So I want the end mill to go around this perimeter. So I'm just going to clip that. And that should have connected all of those, which it did. And then I'm just going to do Control V to paste, and I'll paste that circle back there. So now I have my vectors all created for machining the inside pocket here, and then for machining the circles where the flange is going to be. Okay, we're ready to start doing our toolpathing. So we're going to go over to the toolpaths tab, and we're going to pin that so it's there. And you'll see I have a bunch of toolpaths here from the job as I did it prior. And I'm going to go through some of these toolpaths and explain how they're going to work so we can properly cut this letter out. So the first toolpath we're going to use is called Pocket Over Holes. And it's basically going to take care of this circle, the larger flange circles. And I'm going to machine those down 0.2 inches. And that's where the flange of the threaded insert is going to rest on. I'm using an Amana 43600, which is a solid carbide double straight flute bit that's made for plastic. The speeds and feeds I'm using are based on Amana's recommendations for the Stepcraft Q machine, which is what I'm running this job on. Your machine, if it's heavier duty or lighter duty, you may have to adjust your feeds and speeds accordingly to your machine's capability and your spindle's capability. So I'm going to do an offset toolpath because I'm cutting out a pocket and it's circular. And I'm going to use a 1/2 inch ramp, which I always use a minimum of a 1/2 inch ramp when I'm using straight bits on my material. So I'm going to go ahead and calculate that and preview it, and you can see I have 2 pockets. So the next thing I want to do is the threaded holes. So I'm going to select the 2 smaller circles, and because I machined the larger circle down 0.2, that's going to be my starting location. I don't need to start at the top of the material. I want to save machining time. The cut depth for this these threaded inserts is 0.394 inches. So I'm just going to round that up to 0.4. So I'm going down, I'm going to start at 0.2 and go down 0.4 inches from there using the same end mill. And I'm not going to ramp this one because it's a small hole that I'm basically machining out, so I don't need to have a ramp for that. And I'm going to use an offset toolpath. So when I click calculate and do preview, you can see now I have the pocketed hole on top for the flange, and then I have the hole for the threaded insert. Now the next thing I'm going to do is the light channels. So I've got to create another pocket toolpath. And this time I'm going to select this inside vector here, the entire vector. And I want to go down, I'm going to start at the top of the material and go down 0.67 inches. That's going to leave me just over 1/8 of an inch of material on the front between the bottom of this pocket and the front of the letter, which is more than adequate for this letter, especially because it's going to be painted a dark color. I'm using a Monotool 43608, which is a solid carbide double straight bit 1/4 inch bit, and it's made for plastic. So that's what I'm using on this one. And again, my speeds and feeds are according to Amana's recommendation, and you'll have to adjust those accordingly to your particular machine. But I am running a chip load of 3.6 thousandths. This time I'm going to use a raster toolpath, mainly because it's not a round object. There's more straight runs here. And I'm going to leave it at 0 degrees, so I raster along the x-axis. And that's because I've got 3 segments of the E that are in the X orientation, and then only this vertical part in Y. So from the machining in the X orientation in raster is going to give me the best time and good result for that. I'm going to ramp my plunge 0.5 inches, and we're going to go ahead and just calculate that. Now when I preview this, you can see this is what we're looking at so far. So I've got the flange, I've got the hole for the threaded insert, and now I have my pocket that goes all the way around for my lights. The last thing I'm going to do here is a profile toolpath, and what I need to do is select the outside vector. I'm going to use that same 43608 end mill, and I'm going to go down, because I have tape, double-sided tape that I'm holding this letter to, I don't want to go much past the bottom of the material because I don't want the end mill to get gummed up with tape. So I'm only going 2 thousandths below the material thickness. And this machine is very accurate, so I know that if I'm at 2 thousandths, I'm just nicking the top of the tape, but I'm getting a clean cut all the way through my material. I'm going to cut along the outside. I'm going to go conventional. No separate last pass is needed, and I'm not using tabs because I'm using double-sided tape. I'm going to do a 20-degree zigzag ramp into the material and click calculate. It's going to warn me that I'm going below the depth of the material, the thickness of the material. I'm going to click OK. And now I'm going to go ahead and preview that. So when I double-click the waste material, this is what I'm left with. There's my letter. There's my flange, my holes, the pocket for the lights. And if I flip this over, this is the front of the letter, which is what you'll see on the wall, and then this is the side we're machining, which is the back. Now that we have the toolpaths all programmed for this letter, we have to go back and make another change to the inner vector. And the reason for this is we're going to have an acrylic cap that's placed on the back of the letter, and that's where the light is going to shine through, be diffused. It's going to show on the edge of the letters, and then it's going to diffuse onto the wall. Well, I have 2 options when it comes to lining that cap on the back. So the acrylic piece is going to follow the profile of the outside vector here. And so it'll be exactly the same shape and size. So when you stack the 2 pieces together, it fits perfectly. Now, in order to ensure that I have the correct alignment and make things easier, I have 2 options. One is I can measure the diameter of the threaded rod and use a small hole in the center of each of these locations that's the diameter of a threaded rod and use the rod kind of as a locating feature. The problem with that is that technically a rod is not the best thing to use for location. What would be better, and what I found works much better and gives me a cleaner end result, is to utilize this inner vector for a locating feature. So when I do the plastic part, the acrylic part of this, what I'm going to end up doing is creating a pocket from the outside vector to the inside vector. And this center part now, instead of being recessed like it was on the letter, it's actually going to, the part outside of that will be recessed. So this will be the original material thickness. And because I'm going to cut outside this vector on the plastic, all of my corners are going to be straight, and my corner here, the inside corners, are going to be rounded. So I need to make sure that this is going to fit properly and snap together. Now the end mill that I'm using is a 1/4 inch diameter here. So I want to draw a circle and just show you what's going to happen when we machine this. So you can see if this is the end mill, when it comes in, it's going to go up to the point where the end mill hits this wall, and this area in the middle is not going to be cut. Okay, so that's a problem that we're going to have there. So what we'll do is we'll add what's called a dog bone fillet to the corner, and that'll actually round out this corner so that the straight corners from the acrylic back piece will fit in there without any interruption from an unmachined part of it. Now, we also have the same problem over here. When the end mill comes in to this side, you can see there's this area here that's not going to get machined. But since this is a lot more complicated here, how I'm going to deal with that is I'm just going to modify the vector on the acrylic part and put a straight line down here so that this part I don't even have to worry about. The acrylic pocket will end right at this point, and that'll take care of that from being an issue. So what we need to do is just create the dog bone fillets now, and that is done over here by going to the fillet tool. So all I'm going to do is take the fillet tool, and I'm just going to add fillets to all of these corners, so that way when I have a square piece, I'll show you, it's going to look like this. So the insert is going to be square, and that way it fits nicely in the corner by adding the dog bone fillets to it. Okay. The other thing I need to do is put a radius on the outside here, but what I'm actually going to do is I'm going to do that radius. I'm going to do a dog bone fillet on the acrylic itself, so that way I don't have to mess with these outside corners right here. So that shouldn't be a problem. The last thing is I have to be concerned with is dealing with this area around where the threaded insert goes, because again, using my end mill here, this is going to be the size of my end mill, so obviously I can't get in to this whole area here. And then when I come on this side and I get into the fillet, there's this area here I can't get to. So what I'll do is I'll redefine the end of the vector on the acrylic to make it fit. So for right now, I'm not worried about that. It'll end up how it ends up. Vectric will only machine far enough in to where the end mill reaches the point of contacting two opposing vectors. So this area will not get machined, and that'll be okay. It won't matter for this. It's going to work out perfectly fine. The main thing was making sure that all of these outside corners here had dog bones on them so that the plastic will fit. So what I want to do is just recalculate the pocket light channel, and we're going to go ahead and preview that again, and you'll see now that it added the dog bones to it. So when I do that, and let's see, I do these visible, this is what we get for the final letter. And this is all set to machine now. So we can bring that out to the CNC and we'll machine the plastic part of the letter out of the 3/4 inch material. And then the next thing we're going to do is work on the acrylic cap for the back of it. Okay, now that we got the pocket and the letter milled out of PVC, it's time to work on the acrylic layer. So the first thing we need to do is remember that we copied the vectors and sent them to a letter E acrylic layer here. So we want to turn that on and then make sure it's bold so it's selected. So we're going to be editing in that layer. Now, if you look here, this was the original vectors of the E before we put the dog bones in and all that stuff. And one thing we're going to need to do is remember on the other letter E, you had these outside corners all had dog bones on it. That's because on the acrylic part, they're going to be 90-degree corners. However, we have these corners here, these three corners, and then there would technically be one here as well. But these three are going to be 90 degrees on the pocketed letter, but we need to add a dog bone to the acrylic for them so that it fits together properly. So we don't need to worry about all these being 90 degrees because the dog bones on the pocket take care of that. However, we do have to dog bone these three here so that it fits. So to do that, it's relatively simple. We'll just go back to the fillet tool. It should have the settings already from when we dog bone the other layer. We'll add dog bones to those three, and we should be all set there. Now the next thing, if you go back to the original letter that we did for the pocket, remember I said we had to deal with this screw hole here and this hole here. And because of the complex shape around there, I wasn't going to try to manipulate that so that the end mill would cut properly. So what we're going to do is on the acrylic, we're going to just reshape the vector here so that we don't have to worry about a pocket in this area or in this area. So to do that, we're going to go back to the acrylic layer, and the easiest thing to do here is simply just draw a straight vector line down in this like that. And what we'll do is we'll pocket everything outside from this vector outside to this vector. So we'll pocket this whole area out above the screw, so it won't be an issue when we place these two together. So what I need to do now is we're going to go into node editing mode, and I want to insert a point here and one here, and then I want to cut those 2 points, and that will allow me to remove the vectors outside that. And now I'll just join these back together. So there's my new vector. And so now what I'll do here is I will pocket from this vector out. And like I said, I won't have to worry about anything hitting that where the screw was. Now I'm going to do the same thing over here, except in this case, I'm going to draw a vector out, down, over, and up. So I'm just going to box in kind of around it. And as long as my 1/8 inch end mill will fit through this channel here and here, we should have no problem. So I'm going to do the same thing here. I'm going to go to node edit. We've already got these 2 points. I'm going to select here. Going to insert a point there, and then use the C key to cut those two. What that'll do is free up this vector, and then I can simply join these two. I may have to zoom in a little bit more and check. And I've got a little hanger there and a small one, it looks like right here. Okay, so now that's all joined together. So now what I'll end up doing on this part is I'm going to pocket out everything from inside here out, and this inside these vectors is going to be left alone. That'll be the original height. So again, this area where we had the weird geometry going around the standoff pocket, I don't have to worry about it. It won't be an issue. All right. The last thing that we need to do is if you cut pocket from this vector to this vector, and then you come back around later and you do a profile around this vector to cut the letter out, there's a possibility you'll end up with a very, very, very thin piece of plastic right on the line of this vector that's uncut. Then you'll need to go back with an X-Acto knife or something and clean that up afterwards. When I use a CNC, I hate to have to do a lot of post work, so I try to make my CNC files and use tooling and things to minimize the work I have to do once the piece comes off the machine. So the easiest way to deal with that is to select the outside vector, then go over here to offset, and we're going to offset this outward about 50 thousandths, so 0.05, and make sure create sharp offset corners is selected. What that'll do is create a new vector, and now what we'll do is we'll pocket from that new vector to this one, so we're slightly pocketing past the vector that we're going to cut the profile out of, and that'll ensure I have a nice clean cut all the way around. So that's pretty much it. This file right now, we're ready to do the cam on it. I did notice that I'm missing a circle for some reason right there for the additional screw hole. So we're good. Now the next thing we'll do is we'll start the cam. So I have a toolpath here called inner flange on acrylic. And I'm going to select that. And what I want to do is I only want to remove about 20 thousandths of material from this inside edge to the outside. I want to make sure I have as much thickness of the acrylic when I look at the side profile of the letter as possible. So in order to do that, I just need to have enough material removed so that I have an alignment feature that'll snap together with the other part of the letter. So 20 thousandths is really all I'm going to take away from this. I'm going to use the same 1/8 inch end mill I'd used on the other project, the other part of the letter. I want to cut this in an offset pattern because what I want to do basically is I want the end mill to follow the outline of the letter. I don't want it to go back and forth and have to deal with small areas like this. The cut time is going to be a little quicker using an offset toolpath. Let's see, I'm going to leave a 1/2 inch ramp, and that's pretty much all I have. Now what we're going to do is we're going to select the inside vector and the outermost vector, and then we're going to calculate from there. Okay, so now you can see our toolpaths here. They follow the new vectors that I have in this kind of squared out area. We're going to go ahead and preview that. And as we zoom in, we could see, if you look at here at the Z, it says Z0. That's the top of the material. So in this area, that's material that has not been removed. And you can see Z says 0, but if I move over to this area, it's minus 20 thousandths, showing that that's what's been pocketed. I've got my 3 dog bones here, and I've got this pocket in the corner, and then this vector was shortened up, so I won't have to worry about any interference from the threaded hole inserts. Okay, so the next step here is we've got to do the holes. So I have a hole in acrylic toolpath. What I need to do is select the 2 innermost circles. My material is 0.1875. I'm going to go down 0.195 here. And that'll put me into the spoil board a little bit, but it'll make sure I have a nice clean cut on both sides. Same end mill, there's no tool changes. I'm going to use an offset toolpath because it's a circle. No ramp because it's a small hole, and then calculate that. It's warning me that I'm going to go into the spoil board, and I'll preview it, and you can see I've got my 2 holes there. Last procedure we have to do is the profile. The profile, we're going to do a 2D profile toolpath. We're going to go down 0.195, which is going to send me into the spoil board a little. Same end mill. We're going to go outside the vectors. No last pass. Now tabs are up to you. I'm using double-sided tape. I didn't want to have to deal with any sanding or cutting or trimming of tabs later. If you want to add tabs, you can certainly do that. Some letters are going to be more difficult than others. The E is pretty simple because there's a lot of straight edges on it, but a letter like an S or an O, for example, would be a little bit more difficult because there's a lot of curves, so you'd have to put the tab along a curve. So completely up to you whether you want to use those or not. I just prefer double-sided tape. We are going to add a zigzag ramp at 20 degrees just so that I enter the plastic at an angle. And I want to make sure that the second from the outside vector is selected. And that's where we're going to cut this from. So we're going to click calculate. It's going to go through the material and hit preview. Now, as you can see here, this is what the acrylic is going to look like after it's been cut. So I have the pocket here and the shortened vector on this side to keep me away from where the holes were. I got my dog bones, and this is all set. So this will be the part that's closest to the wall, and then the letter that we did out of PVC will snap over the top of this, and that's the one that'll have the LEDs inside. So now that the acrylic layer is done, in the next video, I'm going to show you how I did all of the assembly and how we install the letters on the wall.